Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Kami daripada Grup 5 akan menerangkan tentang soalan yang diberikan kami, iaitu soalan 5 berkenaan dengan power amplifier. Saya Muhammad bin Mazlan dan juga rakan saya Wan Airul Aizam bin Wan Ahmad, Muhammad Azrul bin Muhammad Noor dan juga Syazni Liza bin Kamis. For the beginning, saya akan terangkan tentang our filas table. So the pilot test of the problem, we started with the fact that speaker can be used as amplifier of sounds either in AC or DC, and then the idea is try to design the circuit that can receive sound signal and amplifier it by using class A power amplifier. And we're learning the issues that how the circuit can operate successfully, and then the resources needed maybe that design the circuits for receiver sounds and amplifier by simulations result. And then the amplitude modulations AM frequency band to be within the 70 Hz to 5 kHz, the fact. And then the idea is the sound can be amplified from microphone, which is the source, as receiver to speaker as the load as amplifier. And the learning issue is how to make the circuits operate as amplifier. The resources needed as the combine the carrier frequency of sounds that bring information or data with modulations for frequency. And the fact that sounds that amplified can be noise, and the idea is noise can be cancelled out from the sounds that receive, since class A power amplifiers are totally immune to crossover distortions. And the learning issues are how to prevent the noise. And lastly, the resources need all the amplifier use demulator to recover the signal. Maximum signal power to 8 ohm speaker should approximately 6 watt for a frequency large of 70 Hz to 5 kHz. Thank you.
Thank you, Mr. Fuad Mazlan. I'm Iwan Airul. We'll continue with the filas. The fact is, it only used the carrier wave frequency. The power usage was high. And the idea is, the power usage can be lower, but the power efficiency may be affected since Class A power amplifier have poor efficiency compared to other type of power amplifier. Then the learning issues is how to make power usage to transmit the signal sound, and the modulation wave frequency to the carrier wave frequency. Another one fact is design criteria. Class A amplifier, which is simplest design with output signal varies for full 360 degree of the input signal. Also, Class A amplifier have high fidelity, where the input signal will be exactly reproduced at the output. The idea is, in theoretically, maximum efficiency of Class A power amplifier is 50% only. In practical scenario with capacitive coupling and inductive load will make the efficiency more below than 25%. So that Class A power amplifier required a large power supply and large heatsink. Learning issue, how to increase the power efficiency of the design and the resources of needed. In this case, BJT is so biased that the output current flow for the entire cycle of the input signal. Thus, the operating point is so selected that the BJT operate only over the linear region of its load line. So, such as amplifier can amplify input signal of smart amplitude. As the BJT operates over the linear portion of load line, the output waveform is exactly similar to input waveform. Then we go to the calculation. We know that from the question given PO equal to 6 watt and RL equal to X ohm. From this formula, we know that P out equal power out mean VCC power of 2 divided by 8 RL. So with this input, we know that VCC will include around 19.59.
Terima kasih diucapkan kepada sahabat saya Wan Airul Azam bin Wan Ahmad di atas penerangan beliau sebentar tadi. Nama saya Muhammad Azrul bin Muhammad Noor. Saya akan menerangkan berkaitan tentang dapatan daripada kiraan VCC sahabat saya, iaitu Encik Wan Airul Azam, di mana nilai VCC adalah 19.59 volt. Di sini saya akan menerangkan berkenaan dapatan pada osiloskop 1, di mana VCC pada nilai 19.59 volt hasil daripada dapatan kiraan daripada Encik Airul. Saya masukkan satu osiloskop satu dan saya connectkan ke input yang mengikut kehendak soalan, iaitu setting bagi range untuk frekuensi adalah 70Hz. Kemudian setelah itu saya membuat setting di time base, iaitu scale sebanyak 5 millisecond per division, dan untuk di channel A iaitu scale saya setting atau laras kepada 20 mV per division. Selepas itu saya buat simulation, dan daripada simulate tersebut saya mendapat gambaran waveform ataupun gambaran gelombang seperti yang terdapat di dalam slide yang telah dilampirkan di sini. Sekian, terima kasih.
Seterusnya, saya Sajni Lizar bin Kamis menerangkan bagaimana mengukur tegangan pada output osiloskop pada nilai 8 ohm yang diberi dalam soalan dan masih mengekalkan pada frekuensi 70Hz. Sebelum membuat pengukuran, memastikan rangkaian yang akan disimulasikan telah berhubung dengan ground dan juga telah melaraskan time base diputar pada skala 5 mili per second division dan menggunakan channel A, dan juga skala volt division diputar kepada 20 mili. Dan akhir sekali akan menghasilkan gelombang berbentuk sinus yang akan dipaparkan. Sekian, terima kasih.